is that instead of treating each proposition as a single entity, P or Q or whatever, we break each proposition into two elements, the subject and the predicate. Now, as I said last time, you can think of predicates in two ways. The simple way to think about them is the way that you talk about them in grammar, as everything in a sentence apart from the subject. So that's why I had you think of them as like sentences with blanks in them, where the subject would go. So for example, Kermit is green. Obviously Kermit is the subject, so the predicate would be everything else, which would be blank is green. Now the other way to think of predicates, the slightly more sophisticated way, is to think of them as properties of whatever it is the subject of the sentence. So that also works for Kermit is green. G stands for the property of being green. And actually in philosophy we talk about predicating things or predicating properties of entities. So you are predicating greenness on the subject of Kermit when you say Kermit is green. Okay. So that's the sense in which every proposition now has two elements. And it's very simple so long as the subject is the kind of thing that you denote with a name. What kind of thing do you denote with a name?
That particular code, because there's only one.
It's not just that there's only one, but it's that it's definite. Yes, so it would be all the things that we would normally denote with what we call names in regular life, like Kermit is a proper name. But it is wider than that. The category of things that you use a name to refer to in logic includes all definite particular individual things. So this cup you would indicate with a name. So if I wanted to say this cup is yellow, I would do that, where that stands for this cup and this stands for blank is yellow. Things get complicated when the subject of your proposition is not the kind of thing that you denote with a name, is not a definite individual person, place, or thing. When it is a quantity of things, or when it is an indefinite thing, like some cup. If I said some cup somewhere is pink, well, I couldn't use a name to refer to that cup because it's not a definite one, it's just some cup. So I would have to use, when you don't use names to refer to the subject, what is the only other thing that you can use? A variable, that's right. A variable. So I would say something like this. Some cup is yellow. I would start like this. But I can't leave it like this because of the golden rule of variables, which is what?
You can never have a variable without a quantity.
Without a quantifier, yes. That's right. You can never have a variable that is outside the scope of a quantifier. How many quantifiers are there? 2. These correspond to the two kinds of quantity that we came across when we first did categorical propositions way back when. That is, all, universal, or some, which we called particular back then. So, there are only two kinds of quantity. So, obviously that's a huge simplification. I mean, because there are an infinite number of quantities if you're talking in terms of numbers of things. But logic just says, let's divide the world into talking about all members of a class of things or everything else. And everything else gets covered by particular categorical propositions. Now, the two quantifiers are referred to as the universal quantifier and the existential, for reasons that we went over last time. Okay. So, if I were to say some cup is yellow, so this says this cup is yellow. This doesn't say anything yet because it's breaking the rule. You can't have a variable without a quantifier. What quantifier would I need if I say some cup somewhere is yellow? I would be existential because I'm not talking about all cups. I'm just talking about at least one. So I would do that. Now, that says something. Does it say some cup is yellow?
No,
What does it say?
something is yellow.
Something is yellow, that's right, because the big difference between, well, there are two big differences between names and variables. Both of them function as the subject of propositions. The first big difference between names and variables that we've already talked about is names don't need quantifiers, because you know there's only one of them. So you don't need to specify that. And incidentally, as I said last time, the introduction of names means that we can avoid the silliness that we got into when we did categorical propositions last time of treating particular names as if they were universals. Like JFK is unsuccessful in his domestic policy, became all JFKs are things that are unsuccessful, and we had to turn them into universals. We don't have to do that anymore because we got names. We can treat them as distinct individuals. So that's good. So the first difference between names and variables is you don't need quantifiers with names. It keeps it simple. You do need quantifiers with variables. The other big difference between names and variables is that names can have information built into them. This has built into it the fact that it's a cup. That's why it's a little c. That information is there, so you don't need to specify that using predicates. However, all variables are the same. They're just things. You can't build anything into a variable. It's a featureless thing. So if we're going to say some cup is yellow, we have to add the info. First of all, we said this thing is yellow, but we also have to add the information that
This thing is a cup.
this thing is a cup. So where before the cuppiness was built into the name, here we have to add an extra predicate and say of that thing that it is a cup. Okay, so there's the big difference between this thing is a yellow cup. I mean, this is a yellow cup, and some cup is yellow. Is this? You have to, not only do you have a quantifier, you have to add an extra predicate. Now, I think on your homework there was also something like, suppose I wanted to say this thing is a yellow cup. How would I do that? Would I use names or variables?
Now you can use a name in that context.
You would use a name. Even though I'm saying this thing, and we think of variables as things, it's this. This is the appropriate word. It's a definite individual thing. So I would use, let's say T for thing. Now, because I'm saying it's this thing, I have to specify both that it is yellow and that it is a cup. So this cup is yellow. This thing is a yellow cup, and this is some cup is yellow, or a cup is yellow. Okay? All right. Now, also last time, we went over the 4 types of categorical proposition and how they look, how we symbolize them in predicate logic. So, A type is all SRP, and as I said last time, both S and P, when we were doing categorical propositions before, we thought of as classes of things. Well, the way we're dealing with classes of things now is as predicates. So even though P actually stands for predicate and S stands for subject, both of them are treated as predicates. Because the way you say all SRP is you say for everything in the universe, if that thing is an S, then that thing is a P. All whales are mammals becomes for everything in the universe. If it is a whale, then it is a mammal. And the difference, and no SRP is, no whales are, I don't know, helicopter pilots, becomes for everything in the universe, if it's a whale, then we know of it that it is not a helicopter pilot. Some SRP, now the big difference between the universal and the existential claims, besides the quantifiers, is that we treat the universal categorical propositions as conditionals. Because otherwise, why don't you want to say this?
That says everything is S and P.
Yes, so this would say everything in the universe is a whale and a mammal. You don't want to say that. You want to say for everything in the universe, if that thing is a whale, then it's a mammal. Whereas we do want to say, if we say some cats are cute, we'd say there exists at least one thing such that that thing is a cat and that thing is cute. Now, I also talked about the scope of quantifiers. The golden rule for variables is they must be within the scope of a quantifier. The scope of a quantifier is exactly like the scope of a tilde, as I said last time. So, what does this tilde apply to? The whole thing or just P? Just P. If I want it to apply to the whole thing, I have to put parentheses around it. Same deal with quantifiers. So this breaks the rule. Why does it break the rule? Where does it break the rule?
Px doesn't have a quantifier.
Right, this x is outside the range of the quantifier. This one's fine. It is in the range of this quantifier, but this one would be outside of it. There are two ways to fix this. I can either put it in the scope of this one, or I can add another one. Now you might say, well, wait a minute, can you use x twice? Yes, you can, because this x is outside the scope of this one. What you can't do is use x twice within the scope of the original one. We'll see examples of that later on. Now, these two things say different things. Let's say S stands for soft and P stands for, I don't know, purple. Yeah, so what does this say?
Some things are soft and purple.
Yes, this says some things are soft and purple, like your scarf. What does this say?
Some things are soft and some things are purple.
Right, what's the difference?
They're talking about two individual things for each quantifier.
Right. It's not the same thing that is soft. It might be, but it's not necessarily the same thing that is soft and purple. So this says some things have both of those properties. It's the same thing if it's in the scope of the quantifier. So there is something that is soft, and that same thing is also purple. Whereas this one says there is something that is soft, and there is something that is purple. Are they the same thing? Not necessarily. So you're talking about two different things there. That's the difference. Okay? But both of these are grammatically correct. They say something. They don't fail to say something. Whereas this breaks a grammar rule. That is grammatically incorrect because it doesn't, because this one is outside the range of a quantifier. All right. Now, most statements that involve predicate logic will fall into one of these four categories. Very occasionally you will have things that don't. So for example, if you're just talking about things, then you won't need two predicates. So look, open your book to page 414. Light that shines on there.
Sure.
Okay. Zach, everything's groovy. Now, when we're doing this, the very first thing that you have to do always is you have to define your predicates and names if you need them. So, what predicate do you need for everything's groovy? Yes. Let's use G for that, because it makes sense. All right, now, symbolize that. No, it would not. You're going to have to use a variable. Why are you going to have to use a variable? Right, everything is not the name. I mean, if everything is the name of your dog, then yes, that would be okay. You know, you point to him and you say everything is groovy. But everything in this case refers to everything. So, you're going to use a variable. And if you have a variable, you also need, which one? Universal. That's right, because it's everything. Now, that is the correct symbolization of everything is groovy. And it doesn't actually look like any of the four, because it doesn't have a conditional or a conjunction. But that's okay, because you're talking about everything is groovy. If instead you were going to say everyone is groovy, you would need another predicate. What is the other predicate you would need? I'll give you a clue. He.
Is a person.
Blank is a person, yes. Because when you're talking about everyone, what you mean is every person is groovy. Now, if you now have two predicates, it becomes an A type. So if it's an A type, it's going to look like that. You're going to have the universal, and then the main connective in the parentheses is going to be the conditional. Fill in the blanks. What goes here before the conditional?
P sub x.
Yes. And then what goes here?
G sub x.
Yes, so this says, if you read it back in Logic Keys, it says for everything in the universe, if that thing is a person, then that thing is groovy. That's everyone is groovy. But whereas if you're just saying everything is groovy, you don't need a conditional because there's only one predicate. All right, number 2. Right.
S is blank smells.
You get the less salubrious one.
And then backwards E sub x. And then S sub x.
Do I need to put parentheses around SX?
No.
No. So just like with a tilde, you wouldn't need to put parentheses around this for a tilde, you don't need to do it for a quantifier. Yes, something smells. Number 3. Jordan.
Phone is on a roll tonight.
Lucky Tom. First of all, we're going to need a name.
Is it T?
Big T or little t?
Little T.
Little t because it's a name for Tom. All right. Then we will need a predicate.
R is on, or blank is on a roll.
Thank you. Blank is on a roll tonight. Now, it's a bit odd doing these before we've introduced what we're going to go on to later, which is relations and multiple quantifications. Because once you've learned that, there would be a different way of symbolizing this. But for now, let's just use that.
Would that just be like
Don't overthink this.
is it just capital R little T?
Yes, it is.
Oh, okay.
Because you're saying of, you're talking about, the subject is Tom, and you symbolize him using a name, and you're saying of him that he's on a roll tonight. So it's that simple. Let's do number 4. Samantha.
Some galaxies do not have a spiral shape.
Okay, so what predicates are we going to need?
It would be tilde S equals blank.
Wait a minute.
Spiral shape.
Yeah, S, so big S is blank has a spiral shape. When we're defining the predicates, we don't need tildes involved anywhere.
And then
How about G?
it would be galaxies.
Blank is a galaxy. Now, notice that when I'm defining the predicates, I define them in the singular, because if you read it back in Logic Keys, you're only ever talking about one thing at a time. So even if you're saying for everything in the universe, you're taking it one at a time. So for everything in the universe, that thing is groovy. It is true of everything that that thing is groovy. So even though this is saying some galaxies, I'm going to be applying the feature of being a galaxy to one thing at a time, which is why I define it in the singular. All right, now that's the predicates we need. Now tell me, if you had to say which of the 4 types of categorical proposition this is, which one is it? What was that? Oh, that's right, it's an O type. So we know what an O type looks like. It's which quantifier?
It's the backwards
The existential one. And then we know there's going to be an ampersand and there's going to be a tilde involved. All right, so you just have to fill in the blanks.
It would be G little x.
Yes, there is something. There's at least one thing such that a thing is a galaxy, and it is not the case that that thing has a spiral shape. That is the logical equivalent of some galaxies do not have spiral shapes. Good, number 5. Sam.
Every cloud has a silver lining.
If only.
Capital C. Blank has silver lining.
Well, I thought when you said C, you were going to say blank is a cloud. Let's do that. That makes more sense to me. So let's say S for blank has a silver lining. Not that there's anything wrong with what you did, it's just a little bit confusing. All right. Yes, that's all the predicates you need. So what type is this? A, E, I, or O? A type. So we know what that looks like. It's going to be universal, and the main connective is going to be a conditional. Just fill in the blanks.
Capital C. X, then S.
Yes. For everything in the universe, if it's a cloud, then that thing has a silver lining. All right, number 6, Brandon.
Jennifer is either at the office or on her way home.
What predicates do we need?
At the office or Jennifer?
No, Jennifer is the name, that's the subject, so that doesn't get built into the predicate. It's blank is at the office.
Blank is on her way home.
Yes, and it's a little odd to say her there, but we can't really say blank is on blank's way home. So let's just say blank is on his or her way home. His, her, its. Could be a homing pigeon. Or, I don't know, a missile. Let's hope it's not on its way home. All right, so how would you do that?
O or capital O, little j. It's not going to be one of the standard ones, right? Not one of the,
Right, why not?
there's an or.
Not just that. It's not going to be a categorical proposition because it doesn't involve any quantifiers. Because it's just talking about Jennifer.
Okay, so then or sign, capital H, and little j.
That's right. And again, this is one of those cases where the original sentence only says Jennifer once. But when you symbolize it using predicate logic, because you're saying 2 things of Jennifer, you have to use Jennifer twice to say each of the things. She's either Jennifer is on her way home or Jennifer is at the office. Or other way around, but you know what I meant. Let's do number... Yeah, let's do number 7. Hunter.
Some pitchers are good hitters. P, and then blank are good hitters.
Blank is a good hitter.
They're good hitters.
Now, wait a minute. No, blank is a pitcher, I think, would be more appropriate there. Okay, so that's 1. P for blank is a pitcher.
And H for blank are.
Blank is.
Blank is good hitter.
Now, there are some reasons for splitting that, and some reasons for not splitting that. If we were to split that, what would we split it into? is good and is a hitter, yes. And if we were to say, I don't know, let's say, is an athletic hitter, it would make sense to split it into blank is athletic and blank is a hitter. Why is it actually in this case, why would it be a little weird to have good be a separate predicate?
Because if you say it's good, good or
Exactly, because this is one of what we're doing now is taking a little philosophical sidebar. In logic, we make various simplifying assumptions. One simplifying assumption is that predicates can be applied to different subjects. The same predicate can be applied to different subjects. So, you know, you can say of Joe that he's a hitter, and you can say of Jane that she's a hitter. That's fine. But when you say of Joe that he's good, and my cup that it's good, something weird is going on. And the weirdness is the property good. What is strange about the property good, as different from, say, the property of being yellow?
Multiple meanings.
Depending on,
Context.
yes. So in other words, you can say someone's a good person, and the good there means something different from if you say they're a good assassin, right? In fact, you might say they're kind of contradictory. If someone is a good assassin, it's very unlikely that they'll be a good person. So goodness is relative to the subject, which makes it a little tricky to deal with in predicate logic. One way to deal with it is to just think of the property of being a good hitter as a single property. But if it was like athletic or yellow or something like that, those are the kind of properties where we think their meaning doesn't change depending on the subject they're applied to. So let's just keep it simple. Is a good hitter. All right, Hunter. What type is that? A, E, I, or O?
I,
So we know what that looks like.
backwards E, little x, and then P of x, and H of x.
Am I done?
Oh, we need parentheses.
That's right. If we did split it out to, and we said G is good, it would simply look like this. Right? You can do that with, as I said last time, you can do that with categorical propositions. If I said some athletic pitchers are good hitters, then it would look like this.
Can you look that up?
Sure. So the same basic structure is there. It's an I type, so you have the existential and you have the main connector being an ampersand, but instead of just talking about pictures, you're talking about things that are athletic and pictures. And instead of just talking about hitters, you're talking about things that are good and hitters. But the same basic structure is always the same. You can sort of expand things. It's kind of like Lego. You can just stick on extra properties in the appropriate place. All right. No freshman can take this course. Number 8.
The F for freshman?
F for blank is a freshman, yes?
And then C for blank can take this course.
Yes. Blank can take this course. Now, what type is this? A, E, I, or O?
This is E.
E. So we know what that's going to look like. It's going to be universal, main connective, and immediately following the conditional is going to be tilde. Those two always go one after the other. That's something that's going to be important later on. So there's never anything between the conditional and the tilde in an E type. Those always go one after the other.
So that would be F of X, then tilde C of X.
Yes, for everything in the universe, if it's a freshman, then it cannot take this course. All freshmen at ITS. They only acquire personhood in sophomore year. All right, number 9. This one's a tricky one, so have fun with this one, Don.
We're going to F and
Yeah,
C.
We'll use the same one, same
for
ones.
Is a freshman and can take this course. For any X, if it is taking this course, then it is a freshman.
That is right. If I'd written this, as one might be tempted to write, what would that say?
If it is a freshman, then it's taking this course, or can take this course.
Yes, all freshmen can take this course. This would say all freshmen can take this course. This says only freshmen can take this course. Do you remember when we were doing if and only if? Remember that?
Necessary.
And the effect of the word only? The effect of the word only was to do what?
Switch the subject and the predicate.
Well, or switch, in this case, the antecedent and the consequent. Yeah, basically conversion. Well, it has the same effect here. The word only, so when it's all, because actually all A-types are conditionals. They're if-thens. So all freshmen can take this course is this. Only freshmen can take the course is the converse of that. Another way to think of it is what is this is equivalent to its contrapositive. So, what is the contrapositive of that then?
If it is not a freshman, then it is not taking this course.
Right, and maybe that's a simpler way to think about it. If only freshmen can take this course, well, for everything, if you're not a freshman, then you can't take this course. Okay? That's how you do only. So this one was the wrong one. That says all freshmen can take this course. Let's do number 12. Ethan.
Well, all is well that ends well,
What is that?
in terms of what?
In terms of what, where do the words come from?
The sentence, I know the answer. I'm not exactly sure what you're asking for. Oh, you mean like blank?
No,
All
you're
blank.
thinking logically. I just mean, where does the phrase all's well that ends well come from?
Oh, I don't know.
Who's heard that phrase before?
Only many times.
I think we all heard it.
I just don't know where it's
Where it
from.
comes from.
Nobody knows? It's a Shakespeare play.
Oh,
You know these things. Yes, I don't know if that's where it first occurred or if he was using a common phrase, but
It's kind
I
of ironic
suspect
for
he didn't
Shakespeare,
have the
though.
apostrophe error in the sentence though.
right. Yeah, they would have spelt it very differently, probably with W's instead of double L's. All right, so that actually is important that it is a Shakespearean phrase. In other words, it's rather archaic English. With that in mind,
Alright, I put for all things X.
wait a minute, define your predicates first.
Oh, all's blank that ends blank?
No,
All's, oh,
no, because the all, of course, is going to be handled by the quantifier. It's not built into the predicate. So let's say W stands for blank is well, and E stands for blank ends well.
Well, so I said, for all things X.
Universal quantifier.
If it ends well, then it is well.
So you said this. Is that right?
Yeah.
No, it's not right. Why isn't it right? It's because it's not what that means. What that means is it's a rather archaic way of saying all things that are well end well.
Oh, okay.
So in other words, it's the reverse. It's just like blessed are the meek. Remember that?
Mm-hmm.
What is, if you had to say blessed are the meek, that would be a universal. So let's say B is blank is blessed. and M is blank is meek, how would you say blessed are the meek? I'll give you a clue. It's an A type. If it is meek, then it is blessed. All things that are meek are blessed. And the same thing is here. All's well that ends well.
Or you have it backwards.
This is backwards.
Okay.
So in other words, this is wrong. It should be, for all things, if they are well. Wait a minute. I apologize, Ethan. I've just been talking out of my ass. You were exactly right. You reversed it, and I was thinking he's not going to reverse it. So whatever he says will be wrong.
So that was the answer in the book, so I was like, wow.
Oh,
that's so
you cheat.
stupid,
You
huh?
cheat. That way I don't have to apologize.
No, I did a first and then check.
All right. Sure, you say that. You're exactly right. Forget everything I said. You did reverse it, because it does say all's well that ends well, but you reversed the order. We'll erase that part of the tape. Okay. Let's skip over number 13. And let's skip to number 15, in fact. Josh. Define me some predicates.
So L is blank is loyal.
Okay.
And F is blank is fierce. And then D is blank is a Doberman, and G is blank is a German Shepherd.
Now notice, we mustn't be too literal here, because that says two things, two adjectives really, German and shepherd. Is shepherd an adjective? Yeah, we'll treat it as a property, but we don't split that in half. We don't say G for blank is German and S for blank is shepherd. Why not?
Because it's a name of a breed of dog and it specifies.
Right, if we were talking about literal,
Literal
sheep
German
herders
shepherds.
from Germany, then we would split it in two, but German Shepherd is a breed of dog. Actually, I don't know why, but in England we call them Alsatians. And Alsace, I believe, is a region that's sort of on the
French.
It's right on the border of Germany and France, I believe. You're not going to contradict me, so I can just bullshit. But yes, Alsatian is what we call them. I don't know why. They're the same big, hairy, vicious dog. All right. So those are indeed the predicates we will need. What type is this? A, E, I, or O, basically.
A.
It's an A type. Okay, so we know it's going to look something like this. You just have to fill in the blanks.
DX or GX.
Ooh, you didn't fall into the trap. Damn it, I was hoping you would, so it'd be a learning moment, like with Ethan.
Then LX and FX.
Now, what we should notice is something we've seen before, back when we were doing categorical propositions. Where does the word or, we have an or here, but there's no or in the sentence. There are two ands. There's Dobermans and German Shepherds are loyal and fierce, and you used an ampersand here. Why didn't you use an ampersand here? Where does this or come from?
Because you're not talking about things that are both Dobermans and German Shepherds.
Exactly right. If you had an ampersand here, you would be saying, for all things, if that thing, because remember, it's the same thing at every moment, because there's only one quantifier and all the x's are in the scope of it. So for everything in the universe, if there was an ampersand here, you would say, if that thing is a Doberman and also a German Shepherd, it would have to be a crossbreed, then that thing is loyal and fierce. What you want to say is, for all things, if those things are either Dobermans or they're German Shepherds, then we can say of them that they're loyal and fierce. Very good. That was a tricky one. Yes, let's do number 17 then.
Some people who can't swim enjoy sailing.
All right, so what predicates will we need? Let's say P is blank as a person. I'll start you off.
Someone who can't swim.
Well, how about we say S is blank can swim? Because I like predicates to be positive things.
Enjoy sailing.
Yeah, so let's say E for blank enjoys sailing. Apparently in the old days, it was actually fairly rare for sailors to be able to swim. You know, when everybody went around on big wooden boats, most of them couldn't swim. Apparently they thought that it was bad luck if you learned to swim, because then that would imply that you would need it. So when they did need it, they just drowned.
Well, it's
Good times. Of course, they were all dying of scurvy anyway, so probably it was sweet relief. All right, what type is that? A, E, I, or O?
O-type.
An O type. No, it isn't, actually. Although it says can't swim, the thing that it is actually what we're saying about them. Well, let's put it this way. What's the quantifier we're going to need? Existential or universal? Existential, because it's some. Now, so what goes here? In other words, we're talking about a certain group, and then we're saying something about them. What is the group?
People who can't swim.
Right, so notice that the negativity, the tilde, comes in the first part, but we're saying something positive about them, which is why it's not an O type. If it was an O type, the tilde would be here. But we're saying of this group that they do enjoy sailing. So it's an I type. So we would say that's the enjoy sailing part. So what do we put here?
EX and not SX.
That's right. And one more thing to finish it.
Parentheses.
Parentheses. That's right. So there is something. It's a person, and it doesn't, and it can't swim, and it enjoys sailing. That would be the logic he used for it. Okay?
I'd say that something's foolish. Whatever.
Yes, I would too. But they could have life jackets on or something like that. And after all, you got to die sometime.